And now the next attribute is spread. So in order to show you the spread, I am going to add one more thing into the scene and atmosphere so that you can get an idea better from this. So what I've done is I have added an atmospheric volume to this so that you can see the light, the area which is getting lit by the light here. So you can see it only lights an area up till this one, and all the attributes which you are seeing here is from the indirect, and by default the light casts light till the 180 degree of its surface. And let's go back to the light spread, and if I decrease the spread, you can see it focuses the light onto the areas which is perpendicular to the light surface. If you want to mimic the effect of a spotlight using Arnold area light, this is the option. You can adjust the spread and it will act as a spotlight. So one drawback of the spread is that, let me just quickly sample this area and put a screenshot here and just reduce the spread. You can see the amount of noise has increased a bit. So I guess it will be clearly visible in this areas, I hope. So here it's almost clear, and if I concentrate or focus the light to this area with the somewhat similar intensity, you can see how much noise it creates. So beware of using this too much because it can produce noise, and we have options to reduce the noise, and we'll talk about it further in this tutorial. But this is something that you have to keep in mind when you are adjusting this spread. The next thing is the resolution. And for that, I am going to do another thing. I'm going to assign this side wall another shader, probably an AI standard surface. And I'm gonna set the weight to 1, color to 1, and metalness to 1, and then the roughness to probably 0, just to show you what it actually means. So by default, if I render this in from the perspective shape, let me just increase the resolution a bit so that you can clearly see what changes it will bring. So if I am changing the resolution, let's say to 32, you won't notice any changes in here. So let me just screen grab this screenshot, put a screenshot here. Then I'll go to 1024. There is no visible changes here, but the same thing if I go to this reflection of the light here, let me just rotate the light a bit, and then in here, this is 1024. Let me just put a screenshot, and if I change the resolution to 32, you can see what the difference is. So in the reflection, it calculates a lower resolution texture when we change the resolution of the light. If we have, let's say, a light which has a texture resolution of 4K, and if we are using a resolution of 512 by default, it means it won't be taking full resolution texture when it is calculating the indirect bounds, or in this case, it's a specular reflection. So keep that in mind, that it's more probably visible when you're using HDRIs, and it by default has a resolution, I guess, 1024 on the AI dome light, which we'll talk in detail when we do a tutorial on AI dome light. So I get you guys get the idea. This is only used for the reflections, and it doesn't have any direct impact on the visibility of the light. And let me put it back to what it was, and let's go back to camera shape 1, 0. Yep, back to where it was. Resolution back to, let's put 8. The next one is roundness. If you change the roundness, it will be better visible in the reflection as well, but for that I'll have to remove the texture, because the texture which we have added right now has a rounded shape. So let me just remove the texture so that the light is square in shape, and let me just remove the atmospheric scatter as well for this, and I'm going to move the light closer to the object. Let me just move back to perspective. So if our surface has pretty good reflections and my area light has no roundness, the shape what we see here is the exact shape of the area light, which is a square quad shape. And if we increase the round, it rounds the edges of the light, and when it is completely one, it creates a perfect circle. And you can use this with the soft edge attribute, which will soften the edge. And let's see what difference that makes in the lighting. So let me just quickly render it out faster, and then we can compare the difference between them. So all these renders are doing with the default render settings on samples. So I haven't changed anything on it yet, so that we can like do it step by step. So let me just save it, and then I'm gonna put the roundness back to 1. And I think it won't change drastically because the area of the light is still more or less the same, and it will have an effect when we are using the spread or something, because then the shape will be different. And let me just add soft edge as well. So you can see when you changed the roundness and softness, you can see when the light became round, the area of the light reduced. That made the light smaller, and that made the light these changes in the shadows. The shadows are a bit more sharper now. So these are all the small changes that can happen if you are tweaking this. And it's not like you can't use this because it is changing the shadows and thing, because it's pretty easier to match it with this one if you can just scale the light, right? If you scale the light, you can almost match it. So this is something that you can do. Like if you are seeing that the shadows are changing, try to move the light closer. And if there are so many objects which are animated, that will make a difference. When you are putting the light closer to the object, it is always advisable to move it as far as you can from the objects, because then you don't have to move or animate the light when the object moves from one place to another, and adjust the scale of the light to match the shadows. If the light were closer and we are getting some softer shadows, and when we move the light far from the object, obviously the shadows are going to get sharper, and then you can scale the light up then to match the difference in the shadows. So that's the trick that you can use when you are using area lights. So let me put those values as well back to the default values, and let me just again re-render. Let me put the scale back to 1. And the samples, so the samples on lights will be affected only the noise in the direct contribution of the light, which means that for this I am going to add, since the objects in the scene has diffuse and specular, I'll add a direct and indirect passes of the diffuse and specular, and I'll show you the difference it makes. So if I come to the diffuse and direct, let me just wait till the render finishes. Okay, now if you come to the diffuse direct, you can see the shadows has noise. Diffuse indirect, if I increase the exposure on the handle here, you can see diffuse indirect as well has a lot of noise. And if you come to specular, it also has these noises on the specular highlight edges, and on the specular indirect, if I increase the exposure, you can see a lot of noise. So theory is that for light samples, if you see noise in shadows and if you see noise in direct specular highlights, you change that particular light's samples, you increase it. If the noises are visible in the diffuse indirect or indirect specular or or in triples, the light samples doesn't have any effect on this. So increasing the light samples for those won't affect the scene, but it can increase the render time, because then even areas which are sampled perfectly on where the shadows or the direct specular will be getting more and more samples, and Arnold will keep sampling it even though it is unnecessary. So it will add to the render time unnecessarily. So beware that only increase light samples when you see noises in the direct passes, especially it will be direct diffuse, direct specular. So by sample 1 you can see how much noise here is that. So let me screenshot this. I think I already did, but then again to make sure, and let's put it to a value of 2, and let's just do the region render. You can see how much noise it has already reduced, and let's see how much changes it created here. So I don't see much changes in the specular, so let me increase it to 3, and that seems to have reduced it a bit, but it still has this. So usually I put light samples up to 3. I don't go above that usually, but the good thing will be that if you have to go above light sample of 3, maybe your camera samples are lower. So the final amount of light samples are calculated by the samples we put on the light multiplied by the samples you put on the camera samples. So the value we put is only the exponent value of the actual one. So if you put 3, it will be 3 squared, which will be 9 camera samples per pixel. And if you put 3 in light, it is again 3 square, which is 9 samples per light, and multiplied by both, it will be in total 9 multiplied by 9, 81 light samples per pixel. So if let's screenshot this again, and let me put it to, let's say 5, and see if that, you can see it has far better sampling when we increase the camera samples. So usually I do put 5 or 6 final samples in camera, and for testing purposes I start with low, but then again when we reach the final stages I'll put the camera samples to 5, especially when it is time to sample or reduce the noise in the scene. This is where I start. I'll start with the camera sample of 5 and then camera samples of 3. And after putting all the diffuse and specular, all the indirect samples and all, it is all finalized. And again, if I am seeing any particular lights which is creating more noise in the direct, I'll definitely increase the light samples to 4 or 5, and any other value which tends to like reduce the noise to an optimum amount which is satisfiable for me. So let's see the specular indirect now. And since we have increased the camera samples a lot, you can see it's not that much visible in the indirect. Noises has reduced a bit. So let's say we want to reduce the indirect noise here. I'm just screen grabbing this, and I'm going to put a value of 10 in the light samples, and you can see it doesn't make any difference because the light samples doesn't do anything to indirect rays. So if I come to the render settings and change the diffuse samples from 2 to 3, you can see some changes. You see, it reduced noise. And again, if I put 4 samples, it almost to a point that is there is not much visible noise here. You can see it's far better. Similar thing in the specular indirect. This will be controlled by the specular indirect samples. So here again, I think we have to go much higher, and the more you increase the indirect samples, the more render time it's gonna add. So we'll talk more about sampling in detail in another tutorials, so you can see how much the noise is reduced. And one more thing is that if the beauty doesn't show any noise, you don't have to go to each AOV and reduce the noise there, because if the beauty doesn't show noise, probably it's not going to show in the final render. So you don't have to change any of the settings there. So let me go back to next attribute, normalize, which we have talked already about. Cast shadows, as the name suggests, it won't cast any shadows if I turn it off. So the light is not shooting any shadow rays, which is not calculating any shadows, so we don't get any shadows. Shadow density, it's like the opacity of the shadow. If we put it 0, again it like turning the cast shadows off. So in some cases we can adjust the shadows, which is like an artistic purpose. It is not a physically accurate thing. It breaks the physicality because real world doesn't have any option to like reduce the intensity of the shadows with each light. You can't control it in the real world. And then we can add a bit more color onto the shadow. This is like a CG thing. Most of the CG movies do this to create more color composition or design elements or design wise decisions. So you can see if you are seeing a more bluer skies, the shadows will have more cast from the blue sky and the shadows will look more bluer. That happens because real world has a lot of indirect bounces or global illumination, and if you don't want to use global illumination because of the much higher render times and you want to mimic it a bit, you can probably use this option. This will be a much effective in terms of render time. If you are using a physically accurate workflow, don't ever touch it. So the next option is cast volumetric shadows. So for that, I have enabled the atmospheric volume back on, and let me just put the color to 0 now. To show this, let me just duplicate our sphere and move it up. Now you can see it creates this shadow on the volume. So you can see here it creates this shadow on the volume here, and if I turn the cast volumetric shadows off, it won't cast those shadows in the volume. So that's that. And the next thing would be the volume samples. This is more like an samples which is usable when we are working with volumes or the Arnold volume shader. So increasing the samples will give you better results in the scatters, and also you can use the volume indirect as well on that one. The next one is the visibility sliders. As you have seen, the camera visibility slider turns off the light visibility in the camera. So let me just put the scatter to 0 and the light is completely invisible now. So let me put the values back to 1 again. And transmission, if the surface is glass, let me just put a cube really quick, and let me just put it in front of the light. And let me just rotate the light facing the camera, and let me assign a glass shader. So standard surface, going to the transmission and put the transmission to 1. And now let me select the light and put the transmission visibility to 1. You can see now the light is visible through the glass shader, and let me put it back to default. And now if you change the diffuse slider, the diffuse component of the shader won't get any lights, only the specular is visible now. And if I reduce the specular to 0, all the specular on the shader is gone from that particular light. Triplus, similar thing. If I am putting any subsurface value here, let me just put something. Now it's a scattering object, and if I reduce the triplus, it's completely gone. So I have put only 77% of the triplus. That's why we are able to see some diffuse here still. You can see it's diffuse. So if I put it completely 1, you can see it's completely black. So let me put it back, and that's triplus. Then indirect, you get any indirect bounces which is casting on from the light to the objects is gone. So if I go to any indirect passes, it's gone. and the specular is still there, so because it's only affecting diffuse or triplus. So if I add the triplus back on, let's see if I'm getting anything in the triplus. So direct and indirect, I'm adding the AOVs, and triplus direct has information, indirect doesn't have anything. So let's see if putting that back, you can see it creates those packs. So I'm not sure why it is particularly given it as in the name of indirect and doesn't affect specular indirect. So it's tricky. So keep that in mind. So volume, as you have seen before, um, you can obviously have this idea like what is going to happen if I change the slider with the scattering present in the scene from the light. If I put it back to 0, the light won't cast any atmospheric scatter information. So you can adjust the amount of scatter volume you need with this. If there is multiple lights present in your scene and the value you have put globally in the atmospheric volume density, you don't want to change it and you want to control the intensity of the volume only a particular light, this is where you control it. And the same thing that you want to control any diffuse or specular triplus of that particular light on any objects, which is again is not a physically accurate workflow. It's gonna break the physicality of the shader and light if we are tweaking this, and everyone is against tweaking this unless until it's really necessary for you. So keeping these settings as it is the best way of working. I would also suggest that unless it is really necessary, don't touch all of this, especially in the beginning of the lighting where you don't want to break the scene that much so that you are sailing away from the photorealism in the lighting and rendering.